Okay, so we've seen how we can categorize the data. How do we improve the picture to make it more understandable? We can see the relative portions in each category, but how about understanding the data set as a whole? Well, there's a number of ways we can do it. We can use colors, for example, to help understand the categories, or we can sort the data to help understand the categories, or we can group some of the products together. And all of those things will be useful. So the first example is to color each category. So we have to create a list of colors, one for each category, by adapting this category code. Sorry, the slide says one for each product, but actually we're creating the colors are one for each category. And if the total sales are over 100,000, then we're going to change set that to green. And if they're over 50,000, actually could be 40,000 as we used before, then it'll be orange. And if they're over 10,000, then it'll be red, and anything else will be black. So it's just setting it's quite a common color chart: black, red, orange, green, which then gives you a different color to try and highlight what some of the possible categories are. Okay, so this is kind of similar to the code we used to do the automatic categorization, but it's now assigning colors rather than assigning them to categories. And then if I want to draw the chart, the plotting code for that chart is just the same as example one. So exactly the same as the code that we used to generate this picture on the right. But instead of that, I just tell it what the colors of each column are going to be. Okay, so using this, you can see in bold there, but color equals colors. Notice the spelling of color. That's the thing we're giving it. It's the American spelling, but colors is the list that I've created. I've used the British English spelling, and so that's got a U in it. Okay, but you can call it. I mean, you can call that whatever you like. It doesn't have to be called colors. So if we run that code, here's the code. And there's the chart it produces. So it's just the same as before, except now hopefully it's a bit clearer as to what we think each category is. Notice, actually I said it could be 40,000. In this one, we've set the limit to 50,000, which means the G and S in this example, just to show that the limits can change, G and S in this example are now set to medium volume because they're below 50,000. So just depends on what data set you're looking at. You can decide what those things are going to be. Okay, that's one way of doing it. The second way is even easier, actually. We can sort all the products. So let's forget about the colors. They don't illuminate the picture that much, so we'll forget about the colors. We'll just sort all the columns first of all, and then plot exactly the same way as we did in example one. Okay, so all we need for this example 8, is just to add the following line at the top. So once we've read the data in, let's have a look at it in the program. At the top, once we've read the data in, there you can see I'm printing out I'm sorting the data according to the sum of each column, and I'm doing ascending is false, so it's the largest ones come first. Okay. And using this axis 1 tells it to do columns rather than rows. We don't want to sort by rows because those are the dates. Okay, so if I do that, we get this sorted thing, and then again, if I run that, you can see it's much clearer from that picture what are the high volume ones and what are the medium volume ones, and so on, because I can see that all the high volume ones, F, A, and L, are grouped together. All the medium volume ones, J, W, H, S, and G, are grouped together. All the low volume ones are grouped together, and so on. Okay. The final example of improving the picture is to group some of the columns together. So if we look back at that picture, we might think that the last set, the very low volume, are perhaps a bit too, they're too hard to distinguish, and we're not quite sure how much of the total portion they represent. So if I group all of those together, anything that's below 10,000 gets put together in a single group, then I can create a slightly different looking chart where I've got a single column representing all the low volume stuff. That's what this does. So this creates a selected array. So we're going to select certain columns of the data, okay? But I'm also going to create an extra column in the data. Okay, so the selected is going to contain all the columns we're going to visualize in our bar chart, and the extra row in the data is to add up all the other things, all the ones that are below 10,000. Okay, so again, you don't really need to understand how the code works exactly, but you might need to adapt it for your particular data set, in which case you'd probably just change this 10,000. So what am I doing in this? I'm looping over all the columns in the data, this for loop. I look at the total sales for that column, and if the total sales are greater than 10,000, I'm going to just add them to the selected. So anything that's over 10,000 is going to get visualized as a bar in our bar chart. So that selected, remember, contains the columns that are shown in our bar chart. If they're less than 10,000, then I add the data into the others column. Okay, so I've created this extra column in my data which has got all the others, all the things that are below 10,000. I just add those in, and you can do that. This is a nice operation you can do in pandas. You can take one column and add it to another column. I think we saw that last week. I can just add one column to another, and so by adding the column in that particular, adding the data in that particular column, the one that's less than 10,000, I can add it into the others data, and then all I need to do then is to add the others column to the ones that are going to be visualized, assuming I want to do that. And so there we go. I create a column called others, fill it with zeros. If the sales are big enough, I put it in the selected list. Things are going to be visualized, and if not, I add the sales from that column into the others column, and then finally add the others column to my selected list of columns to get visualized. So this data frame now has 26 columns. 25 of them were the ones originally there. It's got one extra column called others, and we're going to visualize selected of those, which are all the ones over 10,000 plus the others. And that's what it looks like. Okay, so you can see right at at the end of it, there's a so let me run that one. You'll see right at the end of the plot, there you go, there's a column called others, which is the sum of all the ones that are less than 10,000. Okay, and of course it's even clearer if you then sort the data before you do that. Okay, so this code is exactly the same as example 10 is exactly the same as example 9, except that in example 10 I sort the data first and then create the others column, and then that's the picture that I get. So I can see immediately that I've got the 3 high volume columns on the left, I've got the medium volume columns next, I've got the low volume columns next, and then I've got the others, which are all the very low volume columns added together. And what it's telling us, regardless of the of the code to do that, the data from the data visualization point of view and the data exploration, we can see that although there are some products that don't sell very much, they're still not insignificant. They're about, if you add them all up, they're equivalent to about one medium volume product. So if you were giving the company advice, you might say, well, don't get rid of them just because they're low selling, because it's still equivalent to having an extra medium volume product. So they're not insignificant. Okay, let's oh yes, we'll just have some guidelines about the bar charts then. So we've seen several bar charts there, and many of the good practices that you use in bar charts are already done in Matplotlib. You can change them, but for example, a good practice in bar charts is to include some space between the columns. Well, that's done by Matplotlib. Sorry, I didn't mean to take over the whole screen. Use horizontal labels if at all possible. So this on the bottom here, I know when I'm doing this video, you can't necessarily see that because it goes behind the picture of me. But there we are. That's a better picture to look at. Okay, so the column, the labels are horizontal, so they're much easier to read. You can, if they're very long words, you can rotate them vertically, but they're easier to read as horizontal. And finally, start the x-axis at 0. We'll talk more about that later. And it's important to order the data appropriately. So actually, this picture isn't as good as our sorted one. So this one here, where we've got a much better idea of what's going on. Okay, I'm going to finish that video there, and then we'll finish off the lecture by looking at pie charts.